M.S. Ramaiah University of Applied Sciences.
Hi students, the aim of this experiment is to determine the percentages of various soil grains finer than 75 microns by hydrometer analysis as per IS 2720. Fine-grained soils consist of particles ranging from 75 microns to 0.2 microns. It is not practical to design sieves having screens of this size. The distribution of finer fraction, which includes clay and silt, is obtained by hydrometer analysis. Hydrometer analysis is based on Stokes' law. When the soil grains are suspended in a liquid medium, they will settle at velocities related to their size. Hydrometer measures the specific gravity of the soil suspension at the center of its bulb. Experimental setup. 2 glass cylinders of 1000 ml capacity, hydrometer, thermometer, weighing balance sensitive to plus or minus 0.01 grams, stopwatch, beaker, sieve 75 micron and stirrer. Experimental procedure. Take 50 grams of dry pulverized soil finer than 75 micron. Place the soil in a dish and cover it with 100 cc of dispersing agent solution containing 33 grams of sodium hexametaphosphates and 7 grams of sodium carbonate in distilled water to make 1 liter of solution. Stir well the mixture. After stirring, wash the specimen into a 1000 ml jar and enough water to bring the level to 1000 ml mark. Keep the clean hydrometer in a 1000 ml jar filled with distilled water and 100 ml dispersing agent solution. Mix thoroughly the suspension in the jar by placing the palm of the hand in the open end and turning the jar upside down and back. Place the jar on a level surface and insert the hydrometer. Start the stopwatch simultaneously. Record the hydrometer readings corresponding to the top meniscus at time intervals of 0.5, 1, 2 and 4 minutes. After 4 minutes, take out the hydrometer from the solution and clean it. Place it in the jar containing distilled water. Using the thermometer, record the temperature of the soil suspension. Record the readings at regular intervals of 8, 15, 30, 60 minutes and 2, 4, 8 and 24 hours after the start of the experiment. Hydrometer should be inserted into the soil suspension only 30 seconds before the stipulated time of reading. The corrections for the reading should be obtained by reading the top and bottom of the meniscus formed on the stem of the hydrometer when it is placed in the jar containing the distilled water. To calibrate the hydrometer, first obtain the cross-sectional area of the jar. For this, measure the distance between 2 graduations on the jar by the scale and record the volume between the two. To determine the volume of the hydrometer, immerse the hydrometer in a jar filled with a known volume of distilled water and note the reading. The difference in the readings before and after inserting the jar gives the volume of hydrometer. Measure the center of the volume of the hydrometer from the lowest graduation mark on the stem. Also measure the distances from the lowest graduation mark to the other marks on the stem of the hydrometer. Data collection and tabulation. The hydrometer calibration table is as shown. The volume of the hydrometer VH in centimeter cube, length between any 2 graduations on the jar LH in centimeters, cross-sectional area of the jar A equal to VH by LH in centimeter square, distance between lowest graduation and neck in centimeters, distance between neck and center of volume of the bulb in centimeters, distance between lowest graduation and center of the bulb H0 in centimeters, and constant K equal to H0 minus VH by 2A are noted. The observations are made as shown in the table. Mass of the dry soil taken for analysis WD, specific gravity of the grains G, top meniscus reading on hydrometer stem, bottom meniscus reading on hydrometer stem, meniscus correction cm, composite correction C equal to cm plus or minus ct plus cd, particle size d, percent finer than particle size n are calculated. The results obtained are as shown in the figure.
Dear students, today we are going to perform hydrometer analysis. Hydrometer analysis is also done to identify the particle size gradation, but this is done for fine grained soils, means whose size is less than 75 micron. Last day we performed sieve analysis for particle sizes ranging from 4.75 mm to 75 microns. Particles finer than that can be graded only by hydrometer analysis. The apparatus required for this experiment include weighing balance. The weighing machine should be accurate to plus or minus 0.01 grams to measure the soil sample. 75 micron sieve. The 75 micron sieve is used to sieve the soil sample and get the sample whose size is less than 75 microns. Stopwatch. The stopwatch is used to measure the time recorded once the soil suspension is prepared and hydrometer is inserted into the sample. Thermometer. The thermometer is used to measure the temperature of the soil suspension as well as the water in the control jar. Two measuring jars, 2000 ml cylindrical jars are used. 1000 ml jar is used for preparing the soil suspension, whereas the second 1000 ml jar is used as the control jar wherein the hydrometer will be immersed when readings are not being taken. Measuring scale. The measuring scale is used to measure the distance between the hydrometer markings and the neck of the hydrometer. A beaker. A stirrer. The beaker is used to prepare the soil suspension with a small amount of distilled water, and the stirrer is used to mix the soil sample. And hydrometer. Hydrometer is the instrument which is used to measure the density of the liquid. Now it consists of a graduated stem and a bulb whose bottom is filled with mercury pellets. Now if you look at the stem, you can see the markings are from 0.995 to 1.030. Between two bigger divisions, it is 0.005, which means if I consider the mark here, it is 0.996. Each big division in between two subsequent bigger divisions, that is 0.995 and 1.000, indicates a reading of 0.001. So this first reading will be 0.996, this will be 0.997, 0.998, 999 and 1. And if you look carefully, you can see each of these divisions are further divided into smaller divisions. So this one small division indicates 0.0005, means 4 decimals. Now if the reading stands over here, it indicates the reading is 0.9. When you come here, it is 0.996, and the next reading will be 0.9965. Similarly, if you come here, this reading will be between two bigger divisions, which indicates this is 1.050. This reading is 1.010. This is 1.015, 1.020, 1.025 and 1.030. Now let us start the experiment. First, measure 50 grams of the soil sample which is passing through 75 micron sieve. So for that I am just going to tear the weight of this beaker and I am going to add 50 grams of oven dried sample. Take 50 grams of sample which is passing through 75 micron sieve and mix it with distilled water, a small amount of distilled water using the stirrer. Once the soil suspension is ready, we will pour this into the 1000 ml jar. Add little more distilled water and stir it completely so that all the soil sample is transferred to the Now once it is transferred to the jar, make the volume to 1000 ml. Now the soil suspension has been made up to 1000 ml. Before starting the experiment, we need to calibrate the hydrometer. So for that, we will fill the control jar for about 700 ml. Now this is filled up to 700 ml. For calibrating, we require the volume of the hydrometer. So for that, we will first immerse this hydrometer in this control jar. Now note the initial reading, it is 700 ml. Once I immerse the hydrometer in this control jar, the level of water will rise. Observe that reading. That gives you the volume of the hydrometer. So once the reading is noted, you can take back the hydrometer. Now after taking the hydrometer, for calibrating, you require the distance between the bottom of the bulb of the hydrometer and the neck of the hydrometer. So measure the distance between the bottom and the neck using a measuring scale. Once that is measured and noted down, measure the distance of each of these calibrating marks in the neck in the stem from the neck of the hydrometer and record those readings also. Once both the readings are known, we will be able to calculate the effective depth of the hydrometer once it is immersed in a soil suspension. Once the calibration of the hydrometer is over, we can find out the meniscus correction. For this, again immerse it in the control jar and observe the readings for the lower meniscus and the upper meniscus. The difference between the meniscus will give you the meniscus correction, which is always considered as positive. Now take the thermometer and find out the temperature of this water. Now in intervals we have to find out the temperature of the control jar as well as the soil suspension. If there is any temperature difference between two, we have to apply the temperature correction also. Before starting the experiment, the soil suspension should be thoroughly mixed. So for that, if we have a rubber cover, you can cover the top of the jar using the rubber cover and turn it upside down. If the rubber cover is not available, you can use your right hand palm, take it, turn it upside down for 3 times continuously, and then keep it on a table. Now immediately after keeping on the table, you have to start your stopwatch and immerse the hydrometer for taking the readings in the first 30 seconds. Now release the hydrometer slowly into the soil suspension and take the first reading at 30 seconds. Now it is 30 seconds and the reading is 1.010. Similarly, take the readings for 1 minute, 2 minute and 4 minute. For all these first 4 readings, the hydrometer can be kept in the soil suspension itself. For those readings which are taken after 4 minutes, you can immerse the hydrometer in the control jar and take the readings. Only before 30 seconds of reading, you can transfer the hydrometer to the soil suspension and take the readings. Once the 4-minute reading is taken, you remove the hydrometer from the soil suspension and immerse it in the control jar. Now for the next reading, which is at 9 minutes, you just have to take the hydrometer and keep it in the soil suspension just 30 seconds before 9 minutes. Similarly, you have to take readings at various intervals and continue it until 24 hours or the soil suspension has settled. And that finishes the experiment.
At MSR UAS, we spark your imagination unlike any other.